Okay, so on to question number 7. How do you calculate the vapor pressure of ethanol? Okay, so the vapor pressure can be calculated using the Clausius-Clapeyron equation. Clausius-Clapeyron. Okay, so I'll just quickly write down what that is. So you can use the Clausius-Clapeyron equation when a question asks you to solve for something that changes depending on like either if temperature changes or pressure changes, what is the new, like let's say if the temperature was increased to this and it started at room temperature at this pressure, then what is the new pressure kind of thing. You can use the Clausius-Clapeyron equation. Okay, so I'll just have like an example question on how we would calculate the vapor pressure of ethanol. So for example, what is the vapor pressure of ethanol at 50 degrees Celsius? Okay, so using the Clausius-Clapeyron equation, R is a constant, so I'll just write it down up here where it came from. And its units, it is 8.314, which is the ideal gas constant. And the units are joules over Kelvin times mole. And another important variable that we need is the enthalpy of vaporization of ethanol in standard conditions. So this is something that is given in a table like in your textbook, or it might be given in the question, but I'm just going to look it up on Google. So enthalpy vaporization standard values. I'll just put ethanol. Okay, so let me just try to find. Okay, so here are the enthalpy of vaporization of different compounds. So ethanol is the same thing as ethyl alcohol. So here it is 38.56 kilojoules per mole. But since our R value is in joules, I'm going to convert from kilojoules to joules for the enthalpy of vaporization value. So that's a J if you can't see it. And this can be converted to joules, 38,560 joules per mole. Okay, so now that we have those two constants, I want to also convert 50 degrees Celsius to joules. So let's see. T1, which is T initial, is equal to 50 degrees. So if we add 273.15, we get T1 is equal to 323.15 Kelvin. And then I also want to find the boiling point of ethanol as well, since that should be given in a question. So it's around 78.4. And we also want to convert this to Kelvin. Which is 351.55 Kelvin. Okay, so P2, I'll just make standard, which is 760 torr. And we are looking for P1, which is the vapor pressure of ethanol at 50 degrees. So this will be question mark. Okay, so we have most of, pretty much all the information we need, and we just need to plug it into the Clausius-Clapeyron equation. So P2 is equal to 760 torr, and we're looking for P1. The enthalpy of vaporization of ethanol we found was 38,560 joules per mole. The R value we are using is the 8.314 joules over Kelvin times mole. And then in brackets, we have 1 over 323.15 minus 1 over 351.55. Okay, so if we solve the right part of our equation, by plugging it all into like a calculator, always make sure to do the reactions that are the equations that are in the brackets first, just because it makes it easier to calculate everything. You should end up getting around 1.159. And then to get rid of the ln on the left side, you take e to the power of both sides. Forget what this term is called. Which is 3.188. And then finally, we just isolate P1 by doing 760 torr divided by 3.188. And we end up with 238.3 torr. So this is the vapor pressure of ethanol at 50 degrees. Okay, so let's see what the junior tutor said. Vapor pressure can also be called the enthalpy of vaporization, denoted by delta H vap. So that's not actually correct. But they also have the Clausius-Clapeyron equation. R is the ideal gas constant, P is the pressure, and T is the temperature. So the units of enthalpy of vaporization is in kilojoules per mole or in joules per mole. And the units for vapor pressure we have can be in torr or ATM, but already we can see that they are not the same thing. But indeed, yes, the Clausius-Clapeyron can be used and then I'll just write down the equation that I have, which shows how to calculate it if you had all these different values. It's always confusing to write multiple brackets, but yep.